Did you know that we can visually show how these two are equal? Let's see how. We can think of a square root as the side length of a square. So if we have a square with an area of 40, the side length of the square is the square root of 40. Now we're going to take the square, but we are going to break it into a square number of squares. So if we have a square with an area of 40, we could break it into 4 squares, each with an area of 10. Now remember, the square root can be thought of as the side length of a square. So if we have a square with an area of 10, that means this side length is the square root of 10. And we could do the same thing over here. So over here, we have square root of 10 plus square root of 10, which is 2 root 10. So we can see that the square root of 40 equals 2 root 10. Now let's do one more example. Say that we have a square with an area of 45. That means the side length of the square is the square root of 45. Now remember, we need to break this into a square number of squares. So how can we do that? Well, we could break it into 9 squares of 5. So when we break it down like this, I can see that this side length is the square root of 5 plus the square root of 5 plus the square root of 5, which is 3 root 5. So I can see that the square root of 45 equals 3 root 5. So this blew my mind a couple years ago when I found out that we can visualize simplifying radicals. And we can connect the visual to the abstract of why we need a square number of squares here. So did this blow your mind? Let me know in the comments.